Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Right, let's have a look at this one. This one's very important because this one has come up a few times in various types of exam papers, let it be samples or mocks or such. So it definitely does test that you know the rules of indices and algebra. So it gives you a hint. It says let y equal to 3 to the power of x as such, and then solve this equation. Okay, right. So let y equal to 3 to the power of x. Okay, so therefore, then this equation here, I need to write it in terms of y's. Okay, so you see this 3 to the 2x? Okay, I'm going to apply this rule to it, and I'm going to break it up into 3 to the power of x squared. Okay, where did I get that from? Well, this rule here tells me that when I have a power to a power, I multiply the powers. Okay, so a power raised to another power means I multiply the powers together. Okay, so when I have 3 to the power of 2x, I could write it like this, or of course I could write it 3 squared to the power of x. That is equally as correct. Okay, the reason I chose this way is because y is 3 to the power of x, so I have my little y in there. Okay, so he will become y squared. Okay, whereas 3 squared to the power of x, well, that's 9 to the power of x. So I've kind of changed my base number, so I have actually made my problem worse. Okay, so that's why I don't consider that option. I consider 3 to the power of x because that's my y. Okay, and it did tell me to let y equal to 3 to the power of x, and therefore this becomes y squared. Okay, so I can write this equation now as y squared minus 12 times y plus 27 equals 0. Okay, so I hope you can see where that came from. That's my y, so I just subbed it in, okay, here. Okay, and the 27 stayed the same, and then the 3 to the 2x is what I've shown you here. Okay, my screen isn't broadcasting, is it? Can you see that, guys? No?
Yeah, I can see it.
Yeah.
Yeah.
Can you? Is it moving? Can you see me circling y squared there? No?
No.
I think it's just frozen. Yes. It's just kicked me out of Zoom now. So just 1 sec now and I'll join again. So you're just looking at a frozen screen. Okay, let me just share the screen. Okay, so that's what I was doing there, and I was just showing you that that's where I got my y squared from. Okay, so that's all the different parts of that equation. And from here, this is just simply a quadratic. So you can solve it using the minus b formula, or you can solve it using factors. Okay, so let's consider the factors of plus 27. The 9 3s will work, or minus 9 by minus 3. Okay, the factors have to multiply to give me plus 27, and they have to add together to give me minus 12. Okay, so the second option there, minus 9 and minus 3, will work. So split the y's into y and y, split the plus 27 into minus 9 and minus 3. So y is equal to 9, y is equal to 3. Okay, we're not quite finished yet, even though it may feel like you are. the reason we're not finished is the variable in our formula or in our equation was x, so therefore we need to solve for x, okay? So we have y being equal to 3x, okay? So therefore 3 to the power of x is equal to 9. I just swapped them around there, okay? And we have 3 to the power of x is equal to 3. Okay, so you could use logs to solve it, or a little bit like what we were doing last week, where we made the base number the same. You could solve it that way. So I'm going to do the base number being the same in this case. So 3 to the power of x is the same as 3 squared. Okay, and I'm just doing it this way because it's easy for this particular case. So just like what we were doing last week, the base number is now the same, so we can let the powers equal each other. In this one, I could write 3 to the power of x as 3 to the power of 1, and therefore x is equal to 1. So there's your two solutions, and yes, of course, you could have used logs, no problem at all. If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.